So the first kind of change we want to be able to make is with the amplitude of the function. And we will note that this is the way that we do it. Anytime we have a number multiplied in front of the sine or cosine function, we're changing the amplitude. We actually state specifically that the amplitude of a sine or cosine function, if we have some number multiplied in front of the sine or cosine function, is always equal to the absolute value of that number a, whatever it is. Amplitude is a magnitude. It tells us how far from the x-axis we go above or below to get the maximum or minimum values. All right, so how do we actually use it? Well, in this case, we've got the function y equals 2 times the sine of x right here. So what we're going to do is we're going to go through the graph and we're going to change the amplitude. And so in this case, our amplitude is going to be equal to the absolute value of 2. That's just 2. Okay, so what does that change for us? Well, let's look at that table that we were just talking about in the last video for the sine of x function and how that changes our value. So here's the set of values that I had from the last slide here. Let's see if I can get this to come down with me here. Okay, so this is a graph right here. These are the plot points that we would use if we were dealing with y equals sine of x, but we haven't multiplied it by 2. So what changes? Well, if we take 2 times the sine of x, then what's going to change is that the y values here on this reference will be multiplied by 2. Very simply, 2 times whatever we had from the sine of x before is our new y value right here. So instead of passing through 0, 0, we'll pass through, well, it'll pass through 0, 0 still, so that's good. Instead of passing through pi over 2, 1, it'll pass through pi over 2. We multiply by 2. 2 times 2. We just multiply each of these values times 2, right? We get our y value that goes with it. So every time we multiply by 2, we just put the new value, and this is our y values in the function that we're going to graph over here. So let me go ahead and get an x and y axis system right here going so that we can see it in action. So what I'm going to do is I'm going to graph it. Here's positive, I'll make this positive 1 right here. So I'll make this positive 2 right here. Here's negative 1. Here's negative 2. All right, and our key points go from 0 to 2 pi for one basic period. So we're going to go 0 to 2 pi also. Here's 0, here's pi over 2, here's pi, here's 3 pi over 2, here's 2 pi. If I kept on going, I would have 5 pi over 2, and I would have 3 pi, and so on. But here's 0. So I'm going to plot my key points from my x values along the x-axis right here. I always want to make sure that I give these values whenever I'm giving my graph, the picture of my graph, right? I won't label everything here. Here's 3 pi. If we kept on going, we'd get out to 4 pi eventually. Here would be negative pi over 2 if we're interested in its location. But okay, so in our key points, what's happening? Well, in our function, we go at 0, we still get y equals 0. At pi over 2, this time we're going to get positive 2. At pi, we're going to get 0 again. At 3 pi over 2, we're going to get negative 2. At 2 pi, we'll be back to 0. And this pattern will continue on. So if this is my single sine function right here, here's a picture of my version of this curve here in blue. Just go around. Right, we follow the bouncing balls right here. These are the values right here. If we kept on following this pattern, we would see that this graph just continues on doing the same thing that it just did. Goes to its maximum, comes back down to the x-axis, would continue down towards negative 1 at the next point, and so on. Negative pi over 2, where would we be at? Well, we'd be at negative 2 this time, and so our graph would look like this off to the left-hand side. And so this is an idea to give you this particular function very easily. You can see what's happening, by the way, in comparison to our original graph when we graphed the sine function before. it went like this. So in essence, we're just doing a vertical stretch by a factor of 2. This is a very easy thing to do once you see it in action, but I think it's helpful to see all of these points laid out on our tables here so that you can do that one-for-one comparison yourself to our two graphs. Okay, so what would we say right here? Well, the values for the amplitude is still equal to, well, it's the absolute value 2, so we said it's 2. The period, we didn't change that. One full cycle is completed within 2 pi, so we say our period is 2 pi. The period, we look for all the possible x values that we could put into the function, and we find our period here is still negative to positive infinity. What does change is the range. Because our maximum and minimum y values change from 1 to -1 to -2 to +2, that's what we will put as our range. So in interval notation, we'll write -2 to +2 as one range. There we go. Okay, more graphing action to come.